Okay, so let's talk about the anthropic principle and what that entails as far as how it proves evidence for there being a God or an intelligent being, for that matter. Next slide. Oh, no, my slides have frozen. There we go. All right. So the evidence of order and design for life to exist, thrive, and achieve high-tech engineering on a global scale. Okay, so all the evidence that science has to be able to prove that in order for life to exist, it not only does life need to exist, but it needs to be able to thrive and achieve high-tech engineering on a global scale, because that's what we are today. So the anthropic principle is going to show the evidence of that. So that's what the anthropic principle is. And here what we're going to do is we're going to learn that the universe has to be so fine-tuned to just be able to sustain life on planet Earth. And when I'm talking about the universe, I'm talking about like everything outside of planet Earth, and then we'll get to planet Earth. So we're just going to talk about planet Earth for right now. Our Milky Way galaxy is a spiral-shaped galaxy, and it's actually the perfect size. In fact, 95% of galaxies are either an elliptical or an irregular shape. The fact that our galaxy is a spiral is unique because that's the only type of shape that would create life on Earth. And it cannot be any bigger or any smaller than the size that our Milky Way galaxy is. Otherwise, what would happen is if it was any bigger, destructive radiation would harm life. And if it was really small, it wouldn't have the necessary elements in the atmosphere and even on Earth to be able to produce life, to be able to produce soil, life in water, and things like that. Anything that is necessary for life to exist. And I'll talk a little bit more of what needs to happen for life to exist. So I thought this slide is really cool because in the Milky Way galaxy, we are here. So that's where planet Earth is in the spiraling arms. And it's actually the most perfect position in the spiraling part of the arm because it's 2/3 of the way away from the center of the galaxy in the Orion. It's called the Orion arm. And if we were any closer to the center of our Milky Way galaxy, there would be no life on Earth because we would die of radiation and we would crash into stars, and there'd be such a huge gravitational pull that would create all that crashing that life couldn't be able to exist. And if we were further away, like much further out on the spiraling arm, we wouldn't be able to have any of the heavy elements that is needed for life to have happened on planet Earth. And what's really interesting is, remember I mentioned earlier about the rate of expansion of our universe? The rate itself, if it was changed by just 1/1,000,000th more of a rate, that expansion would have already stopped by now, and the universe would have collapsed inside of itself, and then stars wouldn't be able to form, and it would be just a complete disaster. There'd be no galaxies that would be able to form or anything like that. So that just goes to prove, like, just galaxy-wise, how fine-tuned our galaxy is. And here's what's really interesting. Not only is the galaxy so fine-tuned from shape, size, and speed of expansion, but even as our sun is the same thing. Our sun is considered to be in its middle age. Okay, so it's just like us, guys, which is the perfect age for photosynthesis to happen for plants. It's perfect age for having a controlled climate on Earth, controlled tides, the controlled rate of radiation, the controlled amount of heavy elements that is caused. So, and this is actually the most stable phase for the sun. Otherwise, it's like shooting off all these radiation rays out of it. So middle age is the perfect, most stable age for the sun. Maybe not for humans, but and probably for women. But we'll just move on. Earth is actually in the most perfect position in the line of the planets. In the line of the planets, we are protected from many asteroids and comets that are actually coming out of the asteroid belt. And I put a slide there right next so you can see where the largest asteroid belt is actually closest to Jupiter. And you know, Jupiter is the next biggest gas planet near us. And Jupiter is in the most perfect position because two things. Because of its size, it has a greater gravitational pull. So that means the asteroids that would be shooting towards planet Earth to come and destroy us, those asteroids are actually getting pulled by Jupiter. And Jupiter is like kind of like our big brother protecting us. And what's really interesting is the centrifugal force of all the planets moving around the sun, and at the rate that they move, and in the fact that we all move, that all the planets move at a different rate in a different position, and it all and they all have different gravitational forces. Like obviously, Jupiter and Saturn, and you know, the bigger gas planets have a bigger amount of gravitational force. What's really neat about that is it creates the most perfect balance for our planet Earth to have life. I'll talk a little bit more about gravity in a little bit more further down. So fine tuning is actually due to the laws of physics. Okay, so the laws of physics of nature are fixed and they're inflexible. Therefore, the fine tuning is a necessity to have life permitting universe. So all these laws of physics is something that can be repeated, it can be tested, and it can be measured. So that's why the fact that our universe is what we can observe and what we can measure all fits the laws of physics as far as how finely tuned our universe is, and even how planet Earth is. So let me talk a little bit about gravity. So I made these little pictures. The gravity for planet Earth is so fine tuned. In fact, if you were to have it on a measuring tape, where it lands on the measuring tape is the most perfect spot on the measuring tape. And if we were like just an inch more gravity, we would be flattened, about like that little cartoon character. We'd be flattened flat. In fact, that's what would happen if you land on Mars. You'd just be squashed flat because there's too much gravity. And any or too little gravity, we'd float away, and so would food and water. Everything would just float away. So the fact that we have the most perfect amount of gravity just is another proof of just this is a natural law, and this natural law is so finely tuned for life to be able to exist. And anything either way, either too much or too little, even if it was moved by just an inch more one way or the other, would be catastrophic for us. What's also really interesting is the Earth's rotational rate is also perfectly finely tuned right now. The rate that the Earth rotates allows rainfall to be distributed evenly where the continents are. In fact, the placement of where the continents are and the amount of landmass that is current on planet Earth is perfect for the distribution of rainfall. So it all kind of ties together. And the tidal wave forces, which is caused by the sun and the moon and their gravitational pulls on us, is perfect to be able to give us that's actually what causes hurricanes and tornadoes. So if we had too much, or if our rotation rate was too fast, what would happen is there'd be an enormous amount of hurricanes and tornadoes and monsoons hitting planet Earth too often, and it wouldn't allow the poles to be able to cool at night, because we would just be going, and all this water would be everywhere. But if our gravitational rate was too slow, then the temperature between night and day would be extreme. It would be so extreme we wouldn't be able to survive. Our days would be too hot and our nights would be too cold. Isn't that interesting? I just thought that was super cool. Here's another thing that's super interesting is our oxygen level. So our oxygen level is perfect for human life, and it's right now it's what is contained in the atmosphere is only 21%, and it's exactly 21%. And if we had just 1% more, it would create spontaneous fires all over planet Earth. And if it was 1%, if it was less than 21% for all of life, we wouldn't be able to live because we'd suffocate. That's why whenever we go scuba diving, or whenever people go scuba diving, you need air. You need, because there is not 21% oxygen underwater. And there's not 21% oxygen in outer space. That's why astronauts need air. But our atmosphere provides the exact percentage of oxygen for life. And here's what's really interesting. And what's really interesting is when we do CPR on people, the amount of oxygen we breathe out of our mouth is 16% oxygen, which is just barely enough to help oxygenate the blood that will help circulate the blood to the human brain to be able to keep the brain alive, to keep the heart going, just enough for the heart to get restarted and get going with keeping that person alive. Is that not interesting? I mean, it's all intertwined, and it's so finely tuned that this couldn't have happened by accident or just out of chaos. So here's what's interesting also about our Earth's atmosphere. Our present atmosphere is the fact that our atmosphere on planet Earth is the exact type of transparency is unique, because if it was any more transparent than it is, we would have too much solar radiation when the sun does its flares and all that. And if it was too little, we wouldn't have enough for plants to do photosynthesis, which is what gives us oxygen in the air, which gives, you know how photosynthesis affects everything from light to warmth, everything. What's even interesting is that there are precise levels of elements that are in the atmosphere. Like there's the exact precise levels of nitrogen, oxygen, carbon dioxide, and ozone that is exactly enough for life to exist on planet Earth. The carbon dioxide has to be so perfect that if we had too much, it would create a greenhouse effect on all over planet Earth, and we'd all just burn up because it'd be too hot here. But if it was too little of carbon dioxide, there wouldn't be enough for life to happen, for plants to happen, and for animals to be able to eat plants, and so forth and so forth. So here's what's really more interesting is about the water vapor. If we had too much water vapor, that would cause the greenhouse effect. So let's say we had perfect amount of carbon dioxide, but not a perfect amount of water vapor, and we had too much, we got the greenhouse effect. So here we have carbon dioxide and water vapor being perfectly balanced with each other, and also with planet Earth to be able to create life on Earth to be perfect. But again, if we had too little water vapor, what would happen is the Earth would get too cold for life to exist. So water vapor actually helps to even warm our water and our Earth. The atmospheric, there is atmospheric discharge, which we know as lightning. If lightning that happens in the atmosphere, if there was too much lightning, planet Earth would burn up because there'd be too many fires. But if there was too little lightning, then it couldn't produce the exact amount of nitrogen that is needed to be in our soil for plants and trees and everything to grow. And it also puts the right amount of nitrogen into our atmosphere. So again, it's all tied together. You know what's really interesting is the fact that all this is so keenly tied together. It creates a delicate balance, not only on planet Earth and in our soil and in our water, but also in the atmosphere and the air. So things we can see and things we can't see are perfectly balanced all around us. Amazing, right? So what have we learned so far? We've learned that the cosmological argument points to the fact that the universe has a beginning. Space, time, and matter all started together, and so that in itself points to an intelligent designer that exists outside of space and time and matter. The Anthropic Principle, I just went through with all the slides, it points to the fact that all this universe is so finely tuned. There has to be an intelligent designer. There has to be an intelligent creator. And the theological argument, which is pretty closely tied to Anthropic Principle, is what I will talk about next week, and that will point out the complexity of the fine-tuning of life that is also evidence for God being the intelligent designer. And that's where we talk more about the life here on planet Earth, which will be interesting talk for next week. So that's it for today on the talk of the Anthropic Principle. Thanks for listening.